Hi friends, very good evening. How are you? Mansi, good evening. Pratap, very good evening. Belated Dasara greetings to you all. I hope everyone has celebrated a festival very joyfully. Yeah, today we are discussing about that Young's double slit experiment. We will see few more concepts of that very important hot topic. Hi Divyanshu, very good evening. Still I am waiting for many of my friends. Radhika, next Rana, where are you all? Mansi, Divyanshu, Radhika, very good evening. How are you? Last time neck to neck between you and one more guy. Did you remember? So today let us see who will be the day's winner. In the last class there was a fierce battle between Radhika and Deepak. Today let us see who will be the winner. And last week I hope it was Deepak who finished the game successfully. Hi Akshay, very good evening. Yeah. So in the last session, let me make a small review. Superposition of the light waves we started, followed by the problems on light waves. There we come across with A is equal to root of A1 square plus A2 square plus 2A1 A2 cos phi. Hi Akshay. And intensity I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. Later we classify interference into two areas, constructive interference as well as destructive interference. Hi Yogesh, very good evening. There we dealt the problems on these two types of interference. Now, question most students got wrong from the last CPP. Which of the following is not common to both light and sound waves? Say it is a polarization which is not common to both light and sound waves. Can anyone? The reason why polarization is not common to both light and sound waves? Because light waves are transverse in nature and sound waves are longitudinal in nature. So it is a polarization that proved light waves are transverse in nature. Goals of the today's session. Today I will go into few more areas. Fringe shift, followed by missing wavelength, followed by polarization and different types of relations in polarization, and finally we crack the numericals. Now light waves are transverse in nature. Very good Radhika, very good. Radhika already started attacking game today. Deepak, where are you? Radhika attacked and she threw the first missile that directly hit the target. Fantastic Radhika, you are already showing your supremacy in running over the problems. And now it is a fringe pattern shifting. So when you observe this figure, S1 and S2 are two slits, and in front of S1 I placed a thin transparent film. This is a thin transparent film, and I am observing the pattern at the point P. When you observe this, due to the introduction of the thin transparent film of thickness T, you will notice that there brings again a path difference between the waves traveling from S1 and S2 to the point P. Because of this, the central branch will be shifted towards that slit in front of which film is placed. Central branch will shift towards the slit in front of which film is placed, and the entire pattern will be shifted. So, how much is the fringe shift? D by small d into mu minus 1 into t. D by small d into mu minus 1 into t. Where small d is slit gap, the gap between S1 as well as S2, and capital D is the distance between the center of the slits and the screen, that is capital D. Finally, it is very clear, the shift in fringe is given by capital D by small d into mu minus 1 into t, mu being the refractive index of the film, mu being the refractive index of the film, small t being the thickness of the film, mu is equal to refractive index of the film, and capital D is equal to distance, small d is equal to slit gap, T is equal to thickness of the film. So, by observing this, fringe shift d by d into mu minus 1 into t, but already we have seen beta. What is beta? Fringe width, capital D by small d into lambda, d lambda by small d. Therefore, d by small d is equal to beta by lambda. Therefore, another formula for fringe shift is equal to beta by lambda into mu minus 1 into t. So, brief recap of this concept. There are two slits S1 and S2. In front of S1, you are placing a thin transparent film of thickness small t and a refractive index mu. When you observe that on the screen, you will notice entire fringe pattern will be shifted towards that slit in front of which you kept the film, and mu is equal to refractive index of the film, d is equal to distance between the center of the slits and the screen, small d is equal to slit gap, and small t is equal to thickness. Now, let us see numericals on this concept. So, this is very relaxing. Hi, how are you? So, in this let us see the first numerical. A thin mica sheet of thickness small d is equal to 2 into 10 power minus 6 meter, and refractive index mu is equal to 3 by 2 is placed in the path of the first wave. The wavelength of the light used in the experiment, lambda is equal to 5000 angstroms. Then the central bright will shift by how many fringes? Question number 1, shift by how many fringes? Question number 2, in which direction? Now the race has started among you. Radhika, Akshay, Mansi, Yogesh, Divyanshu, Vinayak, Pratap Singh. Now the race has started. I will see who will crack the problem very fastly. Just now I fed the concept. Let us have a glance of the problem. There is a thin mica sheet. Thickness is given as 2 into 10 power minus 6 meter. Mu is given as 3 by 2. Is placed in the path of the first wave. The wavelength of the light used is 5000 angstroms. Then central bright will shift by how many number of fringes and in which direction it gets switched. This is the question. Your time starts. I want the shift in terms of beta. Radhika, Yash, Vinayak, Divyanshu, Yogesh, Mansi, Akshay. Race has begun. Now I will see who will declare the answer very fastly. Your time starts. Just I will wait for 30 to 40 seconds. After that I will get into action. Yeah. Time is running out. Radhika, Vinayak, Pratap. I am waiting for everyone's reply. Divyanshu, Yogesh. What is the shift and in which direction shift happens? Yeah. Fantastic, Radhika. Fantastic. Once again you are proving your supremacy in today's session. It is 2 beta upwards. Let us see how it happens. As we know, shift is equal to beta by lambda. Mansi, very good. Mu minus 1 into T. Beta by lambda. Lambda is given as 5000. Angstrom is nothing but 10 power minus 10 meter. And thickness is given as 2 into 10 power minus 6. And a refractive index is given as 3 by 2 minus 1. It is 2 beta. In which direction? Upward direction. Fantastic, Radhika. Radhika is the winner of the first problem. Very great. Now I will take you to the next problem. Problem number 2 on the concept of fringe shift. Hi Josna, welcome to you. Why so late, Josna? I am eagerly waiting for you. In YDSE, when a glass film of mu is equal to 3 by 2 is placed Hi Vinayak Singh, you will also be so cute, provided if you declare the answer very fastly. Okay, next time cute boy will be Vinayak Singh. Let us all wait for Vinayak to declare the answer. Mu is equal to 3 by 2 is placed in the path of one of the beams. The intensity at the position where central maximum occurred previously. Please note down all these problems. Don't be hypothetical. Be practical and crack the problems. Remains the same. I know everyone is a whiz kid. You can crack the problems very fastly. Then thickness of the glass film is equal to how much? In YDSC, again race has started. When a glass film of refractive index 3/2 is placed in the path of one of the beams, then the intensity at the position where central max occurred previously remains the same. Then what will be the thickness of the glass film in terms of the wavelength lambda? Race has started. This time Vinayak will overtake Radhika, or Mansi will overtake Radhika, or Apeksha will overtake Radhika, or Josna, whoever. I am eagerly waiting. Akshay, start the game. I am waiting for you. Your time started. Yeah, waiting for you. Once again I am repeating the problem. In YDSC, when a glass film of refractive index 3/2 is placed in the path of one of the beams, then the intensity at the position where central maximum occurred previously remains the same. Then what will be the thickness of the glass film? Your time started. Yeah, running. Jalli, Vinayak, Mansi, Josna, Yogesh, Divyamshu, Pratap, Radhika, Akshay. I am waiting. Our time is up. This time it is the quiz master who will win the game. See, in the YDSC, when a glass film of 3/2 is placed in the path of one of the beam, the intensity at the position where central maximum occurred previously remains the same. Then the thickness of the glass film is how much? We know that 2 lambda. Fantastic. Again Radhika followed by Mansi. Wow, this time I think today is a neck to neck between Radhika and Mansi. Answer is 2 lambda. N lambda, let us see the solution. N lambda is equal to mu minus 1 into T. For minimum, N is equal to 1. Therefore, mu minus 1 into T is equal to lambda. Therefore, T minimum is equal to lambda by mu minus 1, that is equal to 2 lambda. Very good Radhika and Mansi. And Hrithik, wow, fantastic. Hrithik also entered the game. Very great. Yeah, he also, Vinayak Singh, I am not getting sir. No Vinayak, you will get it. Already solution is there. Sangati, it is not 4 lambda Sangati, it is 2 lambda. Solution is provided on the screen. N lambda is equal to mu minus 1 into T. For a minimum thickness, then N is equal to 1. That means the order must be minimum. Then mu minus 1 into T minimum is equal to lambda. T minimum is equal to lambda by mu minus 1. That is already mu is given as 3/2. 3/2 minus 1. Finally, you got the value of 2 lambda. Vinayak definitely will get boss. Definitely will get. I have a lot of confidence on you. Vinayak, you are great. This time I think. Got it? Vinayak, shall we attack the next problem? So, for the last 2 problems which I have given, Radhika is again leading the race, followed by Mansi as well as Yogesh. I am now entering into the next problem. Shall I? Will you permit me? Fantastic Vinayak, you will get it boss, I know. You are very competent boy in the game. Problem number 3. This time what I am doing, you may ask a question. Why always one sir? Why don't you keep 2 films at a time? Then if we keep 2 films at a time, then what will be the next consequence? That is a problem. The third problem will be on 2 films in front of 2 slits. Let us see what happens in this game. And this is a tough game. I will see who will definitely win this game. Everyone can solve this problem, but it is a time that is deciding a topper as well as relatively the next one. Yes, attack the game. In YDSE, fringes are produced fringes are produced with lambda equal to 4,800 angstroms. One slit is covered with mu is equal to 1.4 and other with mu 2 is equal to 1.7. By doing so, I introduced two slits bars, two films in front of two slits. By doing so, central bright shifts to original fifth bright fringe. Original fifth bright fringe from center. Then thickness of the glass film. This is the problem. I am repeating the problem. Everyone be attentive. But this problem winner is definitely a strong winner, because I changed the problem. Instead of one film, I placed two films at a time, which is very hot cake in JEE level. In YDSE, fringes are produced using lambda is equal to 4,800 angstroms. One slit covered with a thin glass plate or a film of refractive index 1.4 and another with 1.7. By doing so, central bright shifts to the original fifth bright fringe from the center. Here, though their refractive indices are different, their thickness are same. Now, the question here is, what will be the thickness of the glass film? T is equal to how much? Your time started. Yes, this is really a worthy problem. Vinayak, attack. Sangati, Josna, Yash, Divyamshu, Mansi, Akshay. Your time started. Attack. Very fastly you have to crack the problem. In competitive examination, not only solving but also time management is essential. Fantastic, Radhika. Radhika once again proved to be so super, and supremacy is still continued from Radhika. The answer is 8 micrometer. So Radhika got hat-trick. Hat-trick winner of today. After Dasara, Radhika is really exploding like anything. Winner is Radhika. Hat-trick winner. Yes, now let us see how the problem. Very simple. Till now, you dealt with only one film. Here there are two films. So shift by the first one. Delta S1, beta by lambda, mu 1 minus 1 into T. Yes, Vinayak, it is 8 micrometer. Really, Vinayak is very aggressive today. And he is closely following Hrutik. Hrutik, you mentioned the number boss. Lekin kedara unit hai. Sangati also 8 micrometer. Very good. Delta S1 beta by lambda into mu minus 1 into T. Radhika, really you are so super here. And delta S2 beta by lambda into mu 2 minus 1 into T. Delta S is equal to delta S1 minus delta S2, that is equal to 5 beta, that is already given. It is mentioned in fifth bright fringe. Then 5 beta is equal to 5 beta is equal to our general formula beta by lambda mu 2 minus mu 1 into T. Bas, really super here. You are all this year, everyone will be in the corresponding JEE as well as medical colleges. You are really very aggressive. So, the first and foremost very important concept, that is nothing but fringe shift is over. This is very hot area and particularly more prone for the problem solving. So, here the basic concept, brief recap, you are keeping the film in front of one of the slits, because of which fringe pattern will be shifted, and we solved 3 different fantastic numericals. So, in all the 3 numericals, Radhika is continuing her supremacy. Try to overtake her. Mansi, Hrutik, Yogesh, Pratap, everyone should try to overtake Radhika, and Radhika, you should try to maintain your supremacy. Now, I will take you to the next very important concept, missing wavelength. Are you all ready? Respond by continuous messaging with Nog. Yes. So, now it is a time of next concept, missing wavelength. Previously, when you observe the YDSC experiment, the YDSC experiment, this is S1, this is S2, and the point of observation P is like this on the screen. This was a concept you knew. Hrutik, fantastic boss. Now in this case, what I did, in the concept of missing wavelength, why always keeping a P above S1, I tried with an experiment by keeping P exactly in front of the slit S1. I kept P exactly in front of S1. Then because of which what happens, you know, the gap OP has reduced. Previously, this was the gap OP. OP is nothing but center of the screen to the point of observation, the distance between the center of the screen to the point of observation. But by doing in the figure 1, this is figure 1, this is figure 2. Figure 2 is our regular procedure. In figure 1, I drop P exactly opposite to S1, because of which I will find missing wavelengths. That missing wavelength lambda is given by d square by 2n minus 1 into capital D. If I take n is equal to 1, then you will get d square by 2 minus 1 into d, that is equal to d square by d. N is nothing but order. If I take n is equal to 2, you will get d square by 3d. So, now let us for the first problem on this, on the topic called as missing wavelength. In YDSC, I hope everyone is ready to crack the problem in fastest, quickest, more accurate way. In YDSC, I am using a white light. White light is used. In YDSC, white light is used. Slit separation means slit gap is equal to small b. Screen distance is equal to small d, very less than small b. Some wavelengths are missing in front of one slit. then what are these wavelengths? Figure, as you know, this is S1, this is S2, and this is screen. This is point P, this is center of the screen O, and this slit gap is equal to, it is given as small b, and distance between the center of the slits and screen is a small d. This is the geometry of the given problem. Yes, Hrutik, show your ferociousness and aggressiveness in cracking the problem. This is the problem bus. And S1P is the distance from the slit 1, S2P is the slit from distance from the slit 2, and D is the distance between the screen and the center of the slits, and B is nothing but slit gap. Now it is the time. What are the missing wavelengths? Sangati, what do you mean? Capital D? Yeah, Yogesh. Radhika, where are you? Mansi, Divyanshu, Yash, Akshay, Josna, where are you all? Hi Vinayak. I want the missing wavelengths. What are those missing wavelengths? Ritik, beta square by d. Fantastic, Ritik. You told half answer. Mansi, Sangadi, beta square by d. Very good, very good. Yeah, what a spirit among you, boss. Ritik and Sangadi really came very fastly into the game, and they overpowered Radhika. Really, what a surprising. Wow, Ritik, really awesome, boss. Sangadi, really great. Still, yeah, Sangati, great. Now the winner of this game is Sangati. Very, very good. Fantastic, Sangati. Wow, really you cracked the typical example. Very, very great. Sangati. Yeah. So the new rising star enter the game in the name of Sangati. Fantastic, Sangati. Now let us see the solution of this problem. Winner of this problem is Sangati. Now, when you observe this, there is a path difference between the two waves, because the wave from S1 is a travelling straight line path S1P, and the wave from S2 travelling the, some lengthy path S2P. Path difference is equal to S2P minus S1P. Now, when you observe the geometry, the figure is like this. The length between this is D and this is B. So path difference is nothing but S2P minus S1P. This is S2, this is P, this is S1. It is a right angle triangle. Sangadi, thank ba, super. Really, a new star has born today at exactly 7 o'clock. On the name of Sangati. So path difference is equal to S2P minus S1P. S2P is nothing but it is a hypotenuse of the right angle triangle. What I can write? B square plus D square whole to the power of 1 by 2 minus S1P, that is nothing but D. Path difference as per our usual notation delta x. Next, when you observe this, when you observe the missing wavelengths location, you observe darkness, nothing will be there except darkness. So delta x, darkness implies destructive interference. For destructive interference, delta x is equal to, already you have this condition, 2n minus 1 into lambda by 2. for the destructive interference, path difference delta x is equal to 2n minus 1 into lambda by 2, that is equal to b square plus d square 1 by 2 minus d. Okay. Now, when you observe this, you have to do small algebra. I will take d as common, then what I will get? 1 plus b square by d square whole to the power of 1 by 2 minus d is equal to 2n minus 1 into lambda by 2. Okay. Now, when you open this bracket, then what do you get? When according to the binomial expansion, apeksha, when I sir, b is very less than d, then we square b, it will be more smaller than b. That's what I am going to show you. Don't worry. Apeksha, sir, I am late, I missed you over 90% class. Don't worry, Apeksha, but try to be in time for the session so that I can do my level best for you to improve the performance. So, when you observe this, d into 1 plus b square by d square whole to the power of 1 by 2 minus d. So, this will be equivalent to b square by 2d is equal to 2n minus 1 into lambda by 2. Here our task is to find the missing wavelength lambda. So, lambda is equal to b square by 2n minus 1 into d. This will be cancelled out. So, the missing wavelength lambda is given by this. Missing wavelength actual meaning in that location you do not find any brightness because that wavelength has lost. Then what do you find? You will find darkness. When you are finding darkness, we know that interference is called as destructive interference. Therefore, delta x as per the geometry of the figure which you got, b square plus d square whole to the power of 1 by 2 minus d, that is equal to the destructive interference condition which is equal to 2n minus 1 into lambda by 2. So, lambda is equal to b square by 2n minus 1 into d. For n is equal to 1, you will get a missing wavelength is equal to b square by d, and for n is equal to 2, you will get the missing wavelength as b square by 3d. This concept is called as missing wavelength. So, the final expression is b square by 2d. So, b square by 2d is equal to 2n minus 1 into lambda by 2. Now, finally, by changing the value of n, you can find the number of wavelengths that are missing in the concept. Shall we go to the next concept? So, the missing wavelength general condition is nothing but lambda is equal to b square by 2n minus 1 into small d. Next, got it, Vinayak? Very good. Why were you late today, Apeksha? Don't worry, we will make up on some other day in the revision sessions. Now, it is the time of polarization. Interference followed by polarization will make you so clear in discriminating and differentiating the concepts. If I follow diffraction immediately after interference, you will be in a loop, you will be confused. So, my sequence for you to keep the concept very confident, I am bringing polarization immediately after interference. After polarization, we will go back to the diffraction. So, what is polarization? Say for example, when you switch on light in your room, the light goes in which direction? It travels in all directions in the form of a ball like structure, north, south, east, west and all corners covering all 8 directions. So, this type of light has many vibrations. We know that light is an electromagnetic wave. It is comprising of electrical field vector and a magnetic field vector E bar as well as B bar. But for sensation of vision, B bar has no influence. It is the electrical field vector. It is the electrical field vector that is responsible for the sensation of vision. That is nothing but E bar. It is E bar that is responsible for sensation of vision. So, all these vibrations are nothing but vibrations of the electrical field vector, and we can represent them like this. So, totally, if you take the light in the form of a ball like structure, these are the vibrations of which vector? Electrical field vector. Electrical field vibrations in all directions. So, thank you Apeksha, thank you Sangadi. Sangadi is now leading the game. From the fourth problem onwards, this new star has entered the game. So, these arrows are nothing but vibrations of the electrical field vector, but I don't want the vibrations of all these directions. So, I have to restrict the number of vibrations or the number of directions of the vibrations. So, I wanted to restrict and I want to confine them to one particular direction. Confining the vibrations of electrical field vector to one dimension or one direction is defined as polarization. Say here I have represented the ball like structure. This light is called as unpolarized light. Light wave having vibrations in all directions is called as unpolarized light. And these are the vibrations parallel to the board, and there are vibrations perpendicular to the board. Perpendicular to the board means that vibration is coming towards you. That is another vibration called as perpendicular vibration. I shown with the dots, and these arrows are nothing but parallel vibrations, and simply I can show this unpolarized light as all these dots are vibrations of electrical field vector perpendicular to the direction of propagation. This dP implies direction of propagation, and these arrows are nothing but parallel to the plane of the vibration. So, these arrow components are called as parallel vibrations, and these dot components are called as perpendicular vibrations, and this big arrow indicates dP. dP is nothing but a direction of propagation. So, totally this type of representing the light in the form of arrows, these are called as arrow components, and these are called as dot components. This is another way of representing the unpolarized light. When I confine the vibration, implies either I have to remove the parallel components or I have to remove the perpendicular components, then light will be like this. In the third figure, I am showing that I removed the arrow components, just I have only dot components. So, this is called as polarized light, because vibrations are only perpendicular to the plane. I need either parallel components or perpendicular components. Here in this figure, I remove the parallel components having only the dot components. This light is called as polarized light, having only perpendicular components. And in another figure like this, I remove all the dot components, so that I am left with only the arrow components. This is another way of representing the polarized light. So, you got the idea, clear idea of polarization. Light is an electromagnetic wave having vibrations like this, like this, like this. So, light has vibrations throughout 360 degrees. These vibrations are confined to the electrical field vector, because magnetic field vector has no influence in creating the vision. So I remove the vibrations in all directions, keeping only one direction. That way of maintaining the vibrations only in one particular plane is called as polarization. And the unpolarized light has vibrations in all directions, whereas polarized light has vibrations either parallel or perpendicular. So UPL means unpolarized light, PPL means plane polarized light, plane of vibration and plane of polarization. Now, when you observe the plane of vibration, the plane or the area in which electrical field vibrations are there is called as the plane of vibration. Say for example, if the vibrations are there in this area, this area is called as plane of vibration, and all the dot components are removed. So that area in which dot components are removed means where polarization happened is called as plane of polarization. Plane of vibration and plane of polarization are mutually perpendicular to each other. So tomorrow we will see law of malice and corresponding numericals, and in the last class there was a contest question. The magnitude of sum of two vectors is equal to the magnitude of the difference of the two vectors, then angle between the two vectors is equal to how much? So what is this? They have given the magnitude of sum of two vectors, R is equal to mod of P bar plus Q bar is given as mod of P bar minus Q bar, and the winner of this contest is nothing but our last class winner Deepak has got the one atom session free. Congratulations Deepak, really fantastic. But today we missed Deepak, I hope. So today we got a new star in the name of Sangati. So today the tough fight was happened between Sangati followed by Mansi followed by Radhika. Radhika led the game in 3 problems. Sangati came with the typical problem and in the front line. Congratulations to you all friends. So today's contest time in YDSC, white light is used, slit separation is to the screen at a distance small d from the slits. Some wavelengths are missing exactly in front of the slits. The missing wavelengths, already I gave the concept, you can easily crack this. And a brief summary of the today's session, shifting of fringe pattern, on which we have done 3 examples, and missing wavelengths followed by introduction to polarization. In the next session, I will fire the problems of JEE and NEET on the polarization, and for the last 2 weeks, for the last session the winner was Deepak, and today's session the majority problems were cracked by Radhika, and the today's winner is Radhika and new star is Sangati. So today and in the next session we will see who will be the new emerging winner. And I gave the fantastic problems, 11 problems were given in your session. Whoever are participating in that problem, please solve them. Thank you for joining. Fantastic friends, fantastic performance. Thanks a lot.